All right, so the first one we'll take a look at is a rational function, and we're just going to describe the transformations. So there can be up to 6 if you had both stretches, both shifts, and both reflections. Okay, that would be 6. This one doesn't have everything in it, but it's got a few things in it. Anyone think they know how many transformations we have? Yeah? 4? All right, can you tell me let's try to go in order and see what we kind of run into. So what do you think the first number is that you would focus on?
5.
Yep, the 5, and it's a -5, so what's that going to do?
That's horizontal, right?
It is horizontal, yep.
So it would, I don't know.
Yeah.
Shift right 5?
Yeah, that's going to be a shift right 5. Anything that's inside this box is going to be a horizontal. Right? And it's backwards. So minus is going to be to the right, plus would be to the left. All right, so there's one thing. Anybody know the next number we would focus on?
4.
Yeah, we're going to focus on the 4. And that's outside the box, so it's not horizontal. And it's multiplication. So do you know what the 4 is?
Vertical stretch.
Yep. So that's your vertical stretch by factor of 4. Okay, so that's that one. And there's only one more number to focus on, and that's the 6. It's outside the box, but it's addition. So what's that going to do? Yeah.
A vertical shift up.
Yep. So that's going to shift up how many?
6.
Yep. And there's the 3 transformations. The ones we didn't have in this one were the reflections. Okay. How would you know if there was a reflection? What would be in the value?
A negative.
Yeah, you'd have a negative either there. That would make a negative. That would make a reflection over the x-axis, or a negative here would be a reflection over the y-axis. Any questions on describing transformations from a graph? Okay. Okay, so the second one we're going to look at, we're going to use the calculator to describe what happens as we approach a value. Now, why do you think I picked -3 to look at what's going to happen as we approach that? What is that? Yep.
That's what makes it equal 0.
Right. That's what makes the denominator equal to 0. So usually as we get close to what makes it 0, that's where something happens in the graph. So first thing you'd have to do is type in, I already typed in y1. Okay, that's the equation we're going to look at. And we're going to go to the table. And make sure that your table is on ask. And we can't do -3 because that's going to cause you to divide by 0. But what would be a value that would satisfy this top one? Let's just actually, what does that mean first? That means as x approaches -3, how?
From things that are greater than?
Yeah, things the positive side, so things that are bigger than it. So what would be a number that's a little bit bigger than -3?
3.0001. -2.00. No, 9999. My God.
You want to say it one more time?
No.
So, what's your final answer?
-2.999.
There we go, -2.999. Okay, that's a little bit bigger. So in that case, as x approaches -3 from the positive side, what's happening?
It's getting big.
And it's approaching,
Positive infinity.
yeah, the y value is approaching positive infinity. And now let's try a value to approach -3 from the left side. What would be a number I could plug in for that? Yeah, we could try negative 3.001, so we're getting very close to negative 3 from the left side. And what are we approaching in that case? Infinity. The y value, oh, did I forget my negative? That should be a
Yeah, I
negative.
said positive. But it was
Yeah.
negative.
So the top one is negative infinity, and the bottom one is positive infinity. So that's how you can figure out what happens. You don't have to use the table, but it's probably the easiest way. Any questions on that?
How would that be in the test?
Pretty much just like that question. Describe what happens. They'll give you an equation or a function, and then they'll ask you to look at a specific number. Most likely it'll be the 0 of the denominator. And they'll either ask from the left side or the right side using that notation, plus or minus. And then it could be a multiple choice question. I'm not sure if that's what you meant. It could be multiple choice or it could be short answer. It could be either way. So the next problem we're going to look at is a concentration problem. So generally for that, they'll give you an amount of ounces that you're starting with and a percentage of acid that is in those ounces. And you're going to pour in 100% pure acid into your mixture to make it stronger. So the first thing we want to do is to find a formula for the concentration as a function of how much acid you pour into your mixture. So the formula for concentration is the amount of acid divided by the total. So the first thing we got to figure out is how much acid we're starting with in the solution. How much acid are we starting with?
Don't you multiply like 60 by 24?
Yeah, we multiply the 60. We're basically finding 24% of 60. So we are starting with 14.4 ounces. And how much acid are we going to add into the mixture?
X.
Yeah, we're going to add X ounces of acid. And now we have to take the amount of acid and divide by the total liquid. So how much liquid do we start with?
60.
60. And how much liquid do we add?
X.
X. So there's a formula for the concentration. And let's graph it. So make sure when you graph it, you put that in parentheses. So plus X divided by 60 plus X. And we'll think a little bit about the window. So X is the amount of acid that we're going to add. Could we add negative 10 ounces?
No.
No. What's the lowest?
0.
Yeah, you can't add lower than 0. And the highest, there's no limit. It just depends on how much acid you have available. So we'll say maybe we add up to 100 ounces. Now, what does Y represent?
The percentage of acid?
Yes, the percentage as a
Decimal.
it's a decimal in this formula. What's the lowest that the concentration could be in this problem?
24.
Yeah, it can't go below 0.24 because there's no option to dilute it. You either leave it the same or you pour acid in. And what's the highest the concentration can go? 1. So we put a 1, we hit graph, and there's a graph of the concentration increasing the more acid we add. And we want to find out when the concentration is how strong?
40%.
40%. So under y equals, what could I put under y2 to help me do that?
24.
Yep, 0.4. Hit graph. So you don't have to add that much acid at all, really, to get that up where you want it. How are you going to find?
Use intersect.
Yeah, so you're going to do second calc, intersect. Does the guess matter? No, it's just going to cross one time. So just hit enter 3 times, and you get a nice answer. So X is exactly 16 ounces. To get that, you just use that graph. All right, any question on that one? All right, so that's a concentration problem. All right, so this one, we're going to do a few different things. We're going to find the domain, the end behavior model, the horizontal, and the vertical asymptotes. A couple of those are going to be kind of tied together. So we won't have to necessarily do 4 separate things, but maybe a few different things. So let's start by finding the domain. Since we have a rational function, what's the only thing that you're not allowed to do when you have a fraction?
Divide by 0.
Right, you can't divide by 0. So the easiest way to figure out what would make the denominator 0 would be to do what with the denominator?
Factor.
Yeah, we'll factor it. Okay, looking at the numerator, I can tell that that's not factorable. So we're not going to end up with common factors in the numerator and denominator. That's important because if we ended up with common factors, what would you have in the graph instead of a vertical asymptote?
A little circle thing.
Yeah, you'd have the hole in the graph. Yeah. So that's not going to happen on this one. Do you know how we would factor the bottom?
Is it x plus 3 and x plus 4?
Yep. So x plus 3, x plus 4. All right. Now, I think we're ready to describe the domain. Okay, what values of x are you allowed to use?
Anything that's not negative 3 or negative 4.
So all reals except negative 3 and negative 4. Now, if you wanted to write that as an interval, how many intervals would you need?
3.
Yeah, you need 3. And can you tell me what the first one would be?
In the parentheses, negative infinity, negative 4, parentheses.
Yep.
And then negative 4, negative 3. And then negative 3, infinity.
Perfect. So there's your domain. Let's do the vertical asymptotes next because that ties in directly with what we just did. When you write an asymptote, you always have to write it as an equation. Vertical always starts with what letter?
X.
Yep. So x equals. And how do you find the vertical asymptotes? You look for.
I don't remember that. Is it what makes the denominator 0?
Yeah, it's what makes the denominator 0. It's basically the values that are not in the domain. So what are your vertical asymptotes?
Negative 3, negative 4.
Yep. Negative 3 and negative 4. So we got those. And there's our domain. What else? Okay, EDM. EDM. Highest degree term in the top divided by the highest degree term in the bottom. So what's the highest degree term in the top?
X squared.
And in the bottom?
X squared.
It's also x squared. So what's my EDM?
1.
1. Okay, so we got that. Now, the horizontal asymptote is when you look at your EDM and let x get really, really big in the EDM. What are we going to get closer and closer to?
1.
1. You're just going to stay at 1. And horizontal always starts with what letter?
1.
Yep. And there you go. So there's your horizontal, your EDM, your vertical, and your domain. Any questions on that one? All right, so this one, a little bit different than the last one because this time the degree in the top is bigger than the degree in the bottom. Last time the degrees were equal. So when the degree in the top is bigger, horizontal asymptotes go away. They're replaced with something that's more complicated. What's the degree in the top here?
2.
And in the bottom? 1. That's a difference of how much? 1. So our asymptote is going to be a degree 1, the EDA. What does a degree 1 asymptote look like? It's a slant. How about if it was a degree 2 asymptote?
The parabola.
Yeah, it would be a parabola. All right, so this is going to be a degree 1. How do you find our slant asymptote in this case?
Do you have to do the synthetic division?
Yeah, you could do synthetic division, or if synthetic division didn't work, you could do long division. Yep. Okay, what number would go on the outside
4,
and inside?
1, 3, and 2.
And 2. Okay, and how do I do it?
Bring it down, multiply,
Multiply.
add, multiply, and add.
So 4 times 7 is 28. Add. All right, so now we've got enough information. The EBA is right there. We just have to know what we're looking at. So what is the EBA?
X plus 7.
Yep, x plus 7. Now, how could I verify that that is the EBA?
Graph it.
Yeah, you could graph it. So let's graph x squared plus 3x plus 2. And we'll also graph the EBA, x plus 7. We're also going to have a vertical asymptote in this one. They didn't ask for that. But what is the vertical asymptote?
4.
4. So what that's going to do is it's going to break our graph into 2 pieces. All right, so we've got that. I need to put in the denominator. I forgot that. So we've divided by x minus 4. Right, and since that's an asymptote, I'm just going to make that line a little bit thinner. Maybe I don't need to, but let's do that. And let's do zoom 6. So as we get close to 4, we know the graph is going to split. Okay, that is definitely not a complete graph. I can't tell quite what's going on. What do you think I need to do here?
Zoom out.
Yeah, where specifically do I need to zoom out more?
On the left side. Or up top.
Yeah, top and to the
Bottom.
well, top into the which way?
North.
So yeah, we want to go higher, but we also want to go another way at the same
To
time,
the right.
to the right. So we want to go higher and to the right. So to go higher, which value would I change?
The Y.
Yep, the y. Which one?
Oh, Y max.
All right, so let's set that at like 35, and I want to go further to the right. Which one would I change there?
Max.
Yeah. I don't know if 35 is going to do it, but there should be another piece to this graph that I'm not seeing. There it is. Now that red line should look more like an asymptote. All right, what do you think now? Does that look like an asymptote?
Yeah.
Yeah. You could go further down to the left. You're just going to see them getting closer and closer. But that looks good to me. All right, so there's your EBA, which in this particular case was a slant asymptote. Any questions on that one?
So for this is just to make sure that it is an asymptote, right?
Yeah, I just wanted to check. Because if, let's say I get something like, if you made a mistake and you got 2x plus 7 somehow. Well, if I look at that line, I can tell there's no way that's an asymptote because it's cutting right through the graph rather than getting closer and closer to it. So it's just kind of a quick way to check and make sure it's okay. Yeah. All right, so this problem is going to be to solve, and we're going to focus on doing it graphically. If you wanted to try to solve it algebraically, that could be a little tough because it's a cubic and a quadratic. And you can't really use substitution that easily, elimination. So graphically would be a good approach for this one. If you want to solve it graphically, first thing you have to make sure is it's equal to y. These are both already equal to y, so that's good. What would you do next with each of those equations?
Graph.
Yep, you graph them. So I already have them typed in into y1 and y2. And when we graph them, what are we going to be looking for?
Where they intersect.
Yeah, we're going to look for where they intersect. So there's the graph of what they look like. Now I can't see the bottom of the parabola, but do you think that the bottom is going to intersect that blue curve?
No.
Nah. So we don't really need to see anything else. Do you think as you go higher that the blue and the red are going to get closer and closer? No. A cubic always increases at a steeper rate than a quadratic. So the blue is just going to kind of get more and more vertical. I mean, the red is pretty steep too, but the blue is steeper. So the blue and the red are never going to get closer. They're going to get further. All right, so how do I find out where they cross?
Second calc 5.
Second calc 5. All right, and then hit first curve, second curve, and the guess. I like to get the guess at least on the screen. I mean, probably doesn't matter, but sometimes when things are off the screen, it doesn't work. All right, so when we solve this, can you tell me what we're looking for? Like what I should write down?
The 2. Remember the x and the y?
Yeah, the x and the y. So when you're solving a system, you got to have both answers. So 2 ways you could do it. Either just write them in separate boxes, or you could write them as a ordered pair. Yep. So if you round that to 3 decimal places, what would be the x?
0.232. 3.
0.233. Yeah. And how about if you round the y to 3?
3.192.
3.192. Perfect. So that's how you solve a system of equations graphically. All right. Any questions on that one? All right.